Hi class. So we'll look at the next topic from this trigonometry unit, which is on the unit circle. So a unit circle is simply defined as a circle that has a radius of 1 unit. And so this is your grid, just like any other grid. Your horizontal axis is x, and your vertical axis is y, and then there you see the circle. So the equation of the unit circle is given by x squared plus y squared equals 1. So, which is basically Pythagoras, right? Because 1 squared is going to be equal to 1. So let's look at example 1. Determine the equation of a circle with center at the origin of radius 6. So that would just be an alteration of the unit circle. So here what you'd have is x squared plus y squared equal to 6 squared. And so this would be x squared plus y squared equals to 36. Okay, so that's what the unit circle is doing, except it's with the radius of 1. Okay, so let's start looking at some coordinates along the circle. So we've looking at the angle either in degrees or in radians. So now we'll start looking at coordinates. Okay, so this is, if we read the question carefully, it's determine the missing coordinates for all points on the unit circle. So anytime you see the word unit circle, just remember your radius here is going to be equal to 1. Okay, so that's what unit circle means. So the other thing with the coordinates is make sure you pay attention to the signs. Okay, so you notice how it says negative 5 over 8. So x is horizontal, y is vertical. So basically what this is a, so let's draw a grid. Okay, and so here's the grid, and then here's our circle. Okay, so it says negative 5 over 8 and y. Okay, so negative 5 over 8 is going to be on this side of the x-axis. Okay, so let's say this is negative 5 over 8. Okay, and so what you have here is two possibilities, right? Because if your y value can either be in the negative part or it can be in the positive part. Okay, so so what you have here is a triangle, and the radius here is 1. Okay, so you have two triangles, one in quadrant number 2 and one in quadrant number 3. Okay, so there's two possibilities. So now what we do is we just use Pythagoras, right? So we got x squared plus y squared equals 1. And so x is going to be negative 5 over 8. So that's going to be 25 over 64 plus y squared equals 1. And so y squared is going to be 1. So 1 is just going to be 64 over 64, right? We have to have a common denominator. Minus 25 over 64. So that's going to be 39 over 64. Y squared. And then y, so we're going to take the square root, is going to be plus or minus 39, square root of 39 over 8. Okay, so plus or minus two answers because, you know, if we want to list the coordinates, we've got two coordinates here. We've got negative 5, 8, positive root 39 over 8. So that's one coordinate, and then the second coordinate will be negative 5, 8 minus root of 39 over 8. Okay, so again, the reason why we've got two y answers is because the two y answers exist with that negative 5 over 8. Okay, so make sure when you put your points, you know what quadrant you're in. Okay, a variation of that is if they tell you the quadrant, so that means there's only one possible answer. So for B, they tell you you're in quadrant number 2. So same idea, let's just draw the picture. Okay, so this time we don't know our x, and our y value, okay, so again this is radius of 1, here's your x value, and your y is going to equal 5 over 13. Okay, so just do the same exact thing here. We've got x squared plus 5 over 13 squared equal to 1 squared, which is this 1, and then x squared plus 25 over 169 equals 1. And so x squared is going to equal 169 over 169, so that's just equivalent to 1, minus 25 over 169, and that's going to equal 144 over 169. Okay, and so your answer for x then is going to be the square root of that, so that'll be 12 over 13. Okay, and now the thing is, what sign should we give that? Because you're in quadrant 2. So remember, you take the square root of something that's plus or minus. Because we're in quadrant 2, this is going to be negative. Okay, so that's a negative. That's a negative answer because we're right over there. Okay. Okay, now next thing, you saw this type of notation in the previous topic. So this is basically an interval of where we're going to accept the angles. And so basically what this is saying is show the integral multiples of pi over 6 that fit within that. So all you have to do here is basically start by multiplying by 0, and then 1, and then 2, and then so on. Okay, and so when you do that, so you're just going to basically take pi over 6 and you're going to multiply by n, where n is going to equal 0, 1, 2, and so on. Okay, until you get to pi over 6. Notice how it says less than pi, until you get to 2 pi. Notice how it says less than 2 pi, not less than or equal, so that means we don't want to include 2 pi. So then when you do your multiples here, I'll just list them. You got 0, pi over 6 when we multiply by 1, pi over 3 when we multiply by 2, that's in lowest terms. Then we've got pi over 2, 2 pi over 3, 5 pi over 6, pi itself, okay, so that's 6 pi over 6, and then 7 pi over 6, 4 pi over 3, 3 pi over 2, and 5 pi over 3. Okay, so there's all your multiples. Now, if you wanted to draw this out, as the question is stating, basically what this would look like, I'll just put that over here. So here's your grid, and so what would happen is pi over. First off, let's just look at what pi over 6 is. Pi over 6, just to give you an idea what degrees that is. So remember, we did this in the previous topic. You just use the relation of 180 degrees equals pi, or 360 equals 2 pi, and so that equals 30 degrees. Okay, so every 30 degrees you would have a pi over 6, right? So basically what that means, like let's look at quadrant 1. Okay, so quadrant 1, here's your 0. Okay, so just going that way, and then okay, so this would be your pi over 6. This would be your pi over 3, and this would be your pi over 2. Okay, and then we can wrap all the way around using those other additional multiples, right? Like if we kind of wrap around like this one here, that would be our 5 pi over 3, right? Because when we come around, this becomes 2 pi on this side. Okay, so remember, you go counterclockwise. Now, let's talk about this 30-degree triangle. So a 30-degree triangle, a 30-degree right triangle is a special kind of triangle. So you should be familiar when the question, we're going to get to questions where we talk about exact answers. So it's worth knowing the 30-degree angle, the 30-degree triangle. So if this is a right angle, this is 30 and this is 60. And then if we say, again, going with the unit circle, our radius is 1. So it works out that the angle across from 30 is going to be 1/2. And the angle adjacent to 30 or across from 60 is going to be √3/2. Okay, so now we could go around and find out what all these points are. So like for example, if we looked at, let's say, I'll do a couple here. Let's say we did pi/6. So finding out what this coordinate would be here, pi/6, that would be looking at your x coordinate here would be √3/2. And your y coordinate would be 1/2. Okay, so that would be that point. Okay, if we got to the 60-degree angle, or the pi/3. Okay, so pi/3 is same thing as 60. So this coordinate here, that would be now you're looking at it the other way around. It's a 60 degrees. So here your x would be 1/2, and your y would be √3/2. Okay, and then when you got all the way to the top here, that would be 0 and 1. Okay, and so we could keep going around all the way until we get back to where we started. Now the only thing that differs, so I just did all the ones for quadrant 1. The only thing that different what happens is when we go to quadrant 2, now what's going to happen is your x values are going to be negative. Okay, when we get to quadrant 3, your x and your y are going to get negative, and then when we get to quadrant 4, your x is positive, your y is negative. Okay, so it's the same, these same coordinates that we just used here are going to exist in those other quadrants, but the signs are going to be different. Okay, so you just have to watch for that. Okay, so I'll stop there, and so now you can work on the questions that go with this topic.